Hello and welcome to very first lecture in chapter 11, Advanced Panda Operations. Now actually we were doing in previous two chapters, exploratory data analysis, and we are at present for several chapters moving in this region of the data science life cycle. Then question may arise that suddenly why this Pandas operations, because as such we have done two whole chapters on NumPy and three whole chapters on Pandas. But these operations are often used for data wrangling. Data wrangling, as you know, is another name for the exploratory data analysis. So these are often used for data wrangling, and therefore we will start discussing them here. Okay. So that means indirectly what I'm saying is we are continuing with EDA only, exploratory data analysis only, but slightly more techniques, more advanced techniques. Now, as far as this first part is concerned, actually we had already done it in that chapter on Pandas, but we are doing it again just for the sake of revision, because whenever people use Pandas, they often do not use this .lock and .ilock as much as they should. And in future versions of Pandas, you will encounter some errors because many other methods are going to be deprecated soon. So just to have more practice of this. What is this .lock? It is used to access few rows based on some label. Now what is the meaning of word label? So let us take one example data frame, maybe like this. Now if you see this data frame carefully, it is not usual Pandas data frame, because in a usual Pandas data frame, the index is assigned by Pandas itself, and therefore it is 0, 1, 2, 3, 4 like that. Here the index is assigned custom index is there. So that is why you can see that index column Pandas always displays slightly lower to make things clear for you. And these are the real columns while this is index. And it is not 0, 1, 2, 3, but Monday, Tuesday. So the weekdays are there as the index. Okay. Now suppose in this kind of data set you are asked that extract the row for Monday. That means extract this horizontal row. Then lock is the fit case for that kind of extraction, where your index is not 0, 1, 2, 3, but some level like Monday. Okay, MON. Or suppose similarly you are asked another question, extract the row where wind is 26. That is this row. Now there also this 26 is as such value, but you can call it the label for this wind column. So if you want to extract this kind of label based rows, then lock is the fit case. Not only that, you can even extract conditionally. For example, for this data set, if you are asked extract all rows where wind is greater than 20. So that means first row will not come, second will come, third will not come, fourth will also not come, fifth this 26, so it will come, 27 will come, this will not come because I am asking wind greater than 20. So only these three rows will come, Friday, Saturday and Tuesday. Okay. So for that kind of extraction, conditional extraction also, this lock is a fit case. So let us see all these types of case. So in one sentence, we say that lock is for label based extraction. Label based means either your index column or index is having some label rather than 0, 1, 2, 3 default values, or your any one particular column, its value you want to extract on the basis of that. So that is what I gave idea about this lock. It is used for label based indexing. What are labels? Labels are either index names or column names. Okay, so you can use either an index name or column name for extracting some subset of given data frame. Okay, so let us use ilock. I will talk later on. So first lock only. Now this we are creating a data frame. So this is my data frame, and it has this as the rows. Okay, this is also one nice way of creating data frame. In earlier chapters, we used to create data frame using a dictionary, if you remember. Now in dictionary, many people find it difficult to imagine, but in dictionary the key values are the column names, key are the column name, and the value part is given as a list like this. So they are rows. Now since they are specified like this, then it becomes difficult for many, and the row will be then 10, 10, 20, 30 like this as a list. So then instead of that, here this is directly the row specified in this manner. This in that dictionary method, this will be column values. So that means if I put that 10, 20, 30 here, then they will be filled one below another in one column. For example, if I write here column 1 as the key and value, I write this list, then this 10, 20 and 30, they will be filled vertically. But here in the syntax, they are written horizontally. So that is why it creates a kind of confusion in the mind. So if you insist that I want to see the data in my code exactly as it is going to printed in the output, then you can use a list. But the limitation of that method is that you cannot write column header and the values both. You can only write numpy arrays like this in a list, okay, and each array, sorry, each list will become one particular row of your data frame. So you can see exactly in same order your data frame rows are appearing. Then where to find the column headers? Because in key method, that is dictionary method, we used to use key to specify column header. So here you have to specify the column header separately, like column is equal to column 1, column 2, column 3, and index. Now index, this is not compulsory. If I don't write that, then Pandas will allocate the default index. Okay. So at that time, it will allocate default index. I don't know why it has allocated. Maybe I think I should restart the kernel. Yes, now it is saying that index is not defined. So I should remove this and only columns is equal to column. And you can see that now it allocates the default index, right? But I want to demonstrate the use of that lock command. So I want to use a labeled index, and therefore I am using this. Okay. Now this is my output data frame, and I will keep them. I have kept them in a diagram. This because I want to clear this to save the vertical space. Okay, but this diagram will remain in front of you, so you need not worry. It is the same data frame, right? Now this is the data frame. Now I want to use lock to retrieve the based on custom index. For example, someone has asked you that retrieve only row 2, okay, from this data frame. Then it is very simple, df.index row 2. Of course, now my index is in the form of a string. It is not 0, 1, 2, 3. So row 2 I have to write in the in quotes. Okay. So like if I execute it, then you will see that row 2 only is accessed. What are the values in row 2? 40, 50, and 60. So 40, 50, and 60. The limitation, slight limitation, is that the values are actually horizontally, but they are displayed vertically like that. But you can't help it. That is how. Or you can use a then dot .t or something like that, which we have done earlier also. So then you can convert it into appropriate format. Okay. So that is one thing. Supposing next I am asked extract row 3. So then it would be very easy, df.log row 3. But now I am asked further that I don't want entire row 3, but I want only a subset of 3 out of 3 columns. I want say only 1 and 3 column. I don't want this middle column. So fine, row 3 and then write comma and in a list give the labels of those columns which you want. So column 1, comma, column 3, again in quotes. Okay. So this lock is for label based extraction of data. So you are giving label of row and then labels of the columns that you want. Okay. So what will be output of this? Clearly 70 and 90, those two will be outputted. So 70 and 90 that you can see. Okay. Now then suppose I am asked conditionally extract. So from column 2, or rather from this data frame, extract all those rows who have value greater than 20 in greater than 50 in column 2, right? So greater than 50, so this will not come, this will also not come, but these lower 2 will come, and extract all the rows. So that means I want entire row, and that is why I will not specify anything other than the condition that df column 2. So that means value of column 2 in my data frame should be greater than 50. This is the condition, and that condition is itself given as the argument to df.log. Okay. So then df.log and in square bracket create this subset. So it will create a subset of row 3 whole and row 4 whole, because these are the two for which column 2 has value greater than 3. Let us check. So yes, it is giving that row 3 whole and row 2 whole, right? Okay, fine. So this is the application of lock. Now where the ilock is used? Ilock is used for position based indexing. So position based is, that means usually the default index of Pandas. So that is 0, 1, 2. So index positions are not some labels, like here index positions were our custom index row 1, row 2, etc. Here index positions are, in this case also, index was our custom labels, Monday, Tuesday, etc. But ilock is used when the indexes are default indexes, that is 0, 1, 2, etc. Or it can also be used when labels are referred as column names. That is conditional access, as we saw here for this lock. That is also possible for ilock, but for ilock you will see that it creates a slight trouble if you do not take care of it. So it throws error. I will show you the error also first, but it does allow conditional access using column name and value. Okay, so that is this ilock. So let us now take example of ilock. We are talking about the which data frame for ilock. Then I think we are talking about the same data frame. This one only, I think. Just a minute. Yeah. Okay. Now this data frame here, it does not have its index default index like 0, 1, 2, 3, 4 like that. Okay. But I am getting this selected underscore row underscore ilock is equal to df.ilock 2. So that means 1, 2, 0, 1 and 2, right? So that will give me row 3. Okay. So that will give row 3, right? So row 3 is my this particular. So if I execute, row 3 has 70, 80, 90. Let us check if it is the same value or not. Yes, it is 70, 80, 90. So this is interesting. My data frame was having index row 1, row 2, row 3 because I had decided the custom index. So it was printed like this. But internally Panda has still maintained its default index 0, 1, 2, 3, 4. Okay. So as a result of that, if I write 2, then it will index, it will extract these 0, 1 and 2. So that means it will extract this. That is important to remember that you can define custom index for a data frame, but internally they are still stored in Pandas default order. Okay. Then directly access is okay. That is the explanation of previous. Now yes, subset. For example, here it is given that extract row 1 and 2, because whenever this symbol is used, then we know that it is 1, 2, 3, but not including the 3. And extract, so 1 and 2 rows. Okay. And extract column 0 and 1, because this symbol here means that 0 and 0 to 2, but not including the 2. So 0 and 1. Okay. So what will be extracted? Ideally, let us check first. Okay. So 1 to 3. So row 1 is this, because indexing starts from 0. So this is row 1 and this is row 2. So these two will be extracted. Third will not be extracted. Fine. So row 2 and row 3 will be extracted. Fine. Now in columns 0 and 2. So this is 0th column and 0 and 1. So, and this is first column. So from these rows also, this 40, 50 and 70, 80, only that much will be extracted. This third column, its values will not be extracted. So the output should show 40, 50 and 70, 80. That is clear. I hope that it is clear, because 1 column 3 means 1 to 3 but not including 3. And 0 to 2 means 0 to 2 but not including 2. So that means 0 and 1. And this is also 1 and 2. Okay. So these two will be extracted. 40, 50, 70, 80. Let us check. And 40, 50 and 70, 80. The advantage of taking a slice like this is that even the format is proper. What I'm saying is that here columns are below one below another. Now columns have been displayed properly. That is one on the next, one besides another. Okay. So you can take any slice from your data. So I have taken this slice from my data. Okay. So this is one important another use of ilog. Similarly, another a single element if you want to access. Say df.ilog 3 and 1. 3 means 0, 1, 2 and 3. Now that means 0, 1, 2 and 3. Third row. Okay. So this row and in that 1. So 0 and 1. So which element will be extracted? 110. So let us check. And it is extracting 110. Okay. So even a single element, because a single element is also nothing but a very minute slice from a given data frame. Okay. Now those who have worked with that OLAP and etc. Cubes, they know that every database management system or every database and every database manipulating language like SQL or Oracle or whatever, they will provide some mechanism of slicing the data, because every time these are only 4 rows and 3 columns. But in industry, you have to encounter maybe a million row, and which is the data of your employees starting from maybe 1980 to 2020, and maybe 12 columns it is monthly data, or even 48 columns if it is quarterly data. So I mean, you can imagine weekly data. Sorry, you can imagine that every time to suppose your boss has asked that I want to do analysis of data of 2018. Then every time you load the entire data set in your working environment and then do analysis, that is not done. No, so you have to learn to slice the data and access required data frame. Now here we want to do one more example. So I will close this because now this data frame discussion is over. Okay. Now this another data frame. We will create this also, but first I want to show the picture. Suppose there is this kind of data frame, Monday, Tuesday, Wednesday, and all weekdays are there. Weather, temperature, wind, and humidity. These are the 4 columns. Weather has category sunny, cloudy, shower, and temperature is a floating point number. Wind is integer, and humidity is also integer. Now here, suppose I am asked this kind of extract this kind of, forget about this code, because this code is what you have to write. Okay, but this kind of subset from this data set. So what the subset requires? It requires me to access these 2 rows, Thursday and Friday. And in columns, what it requires? It requires me to access temperature, wind and humidity. Weather I don't want. So these 2 rows, Thursday and Friday. So I will start counting from 0, 0, 1, 2, 3 and 4. So that means I want say 3 to 3 and 4. Okay, rows. Or I can specify clearly because it is labeled row. So Thursday and Friday. And in that columns, I can write column also temperature, column, humidity. Now when you write labeled column range, at that time it includes the last one also. That is one important thing, because if you write index the range 0 to something, because indexing starts from 0, but labels will are labels. They will start from their values. So then if you write temperature colon humidity, it will include temperature and humidity also. So this is actually df.log. In first argument is Thursday, Friday, and next argument is temperature, comma, colon, humidity. Okay. Instead of that next argument, you can write a list also, temperature, comma, wind, comma, humidity. Just like first argument, you are specifying rows, Thursday, comma, Friday is a list. Next argument also you can specify as a list. But how many you will go on typing? If these are 3 columns, so fine, but there may be 20 columns. So this colon method is preferred. Okay. So first let us create that data frame. So I am creating the data frame. Its index are custom index. Again, I am using the list method, no, distant dictionary method. So this is my column header, weather, temperature, wind, humidity. Okay. So weather, temperature, wind, humidity, and these are the values in each column. So sunny, 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 cloudy, etc. These are the values in temperature column. So vertical values. So that way we are creating the data frame. Let us display. No, here it is just a data is put. Now data frame is created in next step by pd.dataFrame, and let us display that data frame. Okay. So it is the same data frame here, whatever is there in the picture, but let us create that so that I can actually make you assured that the code which was shown in the diagram that does work perfectly. Now I will clear this cell output, and I will even clear maybe, okay, fine. I will keep this. This is the same data frame, so we will keep this. Now suppose I am asked that from this data frame, find this much, this green colored box. Okay, so that means which rows? Monday, Tuesday, Wednesday, Thursday, these rows. And which columns? Then in the columns, first green color box shows rows, and this orange color box that shows the columns which I want. So I want only temperature and wind column. I don't want other column. So wherever the green and orange intersect, that much slice, this much will be extracted from my data set by using these commands. So what will be extracted? That means Monday temperature 12.79 and wind 13. Tuesday temperature 19.16 and wind 28. So these, where my cursor is moving, this much will be extracted. Let us check if it is properly extracted or not. Okay. So here row I am giving by colon symbol, and when I write colon with label, then label you should not read Monday to Thursday, but not including Thursday, because that is only when indexing starts from 0, 1, 2, 3. These are labels and they start from Monday only. So Monday to Thursday, there are the rows, and in the columns, I will put this list. Okay. So in that case, if I extract, I am getting Monday, Tuesday, Wednesday, Thursday, and only these 2 columns. So I am getting this subset. Okay. So you can get any subset. So that is what here it is shown in picture. Same thing, but before picture I have put the code just for the checking. Okay. So you can check also that it is the same data frame, Monday, Tuesday, Wednesday, and here in the lower part, lower corner, it is the same, right? Okay. For same data set, we can use iLock for selecting columns from position 0 to 3. Now there I have specified in bracket excluding 3. Always remember that is a little bit quirk of Pandas, that index sometimes you specify by label and sometimes you specify by number. If you specify by default index starting from 0, then you will write 0 to 3. 0 colon 3 will be read as 0 to 3 but not including 3 or excluding 3. So this will be 0 colon 3, that many columns, and rows only 1, 2. Okay, so 1, 2 by default. The row here in the picture are the row indexes are Monday, Tuesday, but you have to think internally what are the indexes. Then this is 0, so this will not be extracted. Only 1 and 2. So Tuesday, Wednesday will be extracted, and column 0, 1 and 2, 3 will not be. So 0, 1 and 2 means weather, temperature, and wind. So Tuesday, Wednesday, and weather, temperature, and wind. So that much slice will be extracted. So that I have shown here, Tuesday, Wednesday, and weather, temperature, and wind. Now let us check actually whether it is that only which is extracted, and it is. So please remember this. About this colon symbol, it is source of many errors in your code. Okay, so when labels are used, colon, then whatever you write after colon, that is also included. But when integer index, default Pandas index is used, whatever you write after colon, that is excluded. Okay. Now conditional statement. Now that is the last thing, but that is what is slightly difficult with iLock. Okay. With lock it was very easy. If you remember earlier with lock, we had done the conditional statement very simply by df and df.log, and in bracket we put the condition df column 2 is greater than 50. So that means select only those columns where those rows where the values in column 2 is greater than 50. But here if I try to do that same with ilog, that means df.ilog, and yes, here, okay, df.ilog, df.humidity is greater than 50, then you will see you will get some value error like that. Okay, this kind of error. It shows that location based indexing, location based is with iLock, okay, can only have integer or integer slice, etc. like this. Okay, so how to avoid that error? Then it is very simple thing. Whatever is your conditional statement, you convert it to a list. And how to convert it to a list? Just pre-qualify, write a list word and put this everything in square bracket. Then you will see that this error disappears. So I am doing nothing. List and df humidity greater than 50. Okay, and put everything in this square bracket. That is, take the subset using this condition. So only thing is conditional statement is pre-qualified with list. And if I write that, then humidity greater than 50, only those rows are accessed. For example, this was my entire data frame. So humidity greater than 50. So second row will come the 96, and so Tuesday will come, then Friday will come 79, and Saturday will come. So Tuesday, Friday, and Saturday, right? So it is very easy to get conditional access using iLog also, but that is easy provided you have seen this error occurring once. Okay, so then if you see this error, then you will immediately recall that yes, for log-based conditional access, I don't need anything, and this will work as it is. But for iLog-based conditional access, I will have to use embed my condition inside list. Okay, so a very simple remedy for this error. Then now this part we will do in next, handling time series data. Now again, remember, we are not going to discuss time series. Our aim is not to discuss time series. In fact, time series is a totally different type of special niche area of data science, and it has no relation with rest of the data science. So it has to be discussed in very detail, and there are no normal algorithms help you. That is, these all linear regression, logistic regression, random forest, XGBoost. Don't bother about them. Where are they? We have not yet learned. But XGBoost, SVM, then KNN, then K-means, all these don't help in time series. Okay, what helps is time series has to be dealt in its own separate way. So that's why here you will see we have one whole chapter on time series and a pretty long chapter, very long chapter. Okay, so there we will discuss time series in much detail. But the purpose of this chapter here, handling time series data, is to show the power of pandas, that even in time series analysis, I said that all those things are not useful, that long list of algorithm which I spoke, but you cannot get rid of these two. These two dear friends, pandas and numpy, they are required to do anything in data science, and they are required for time series also. So our aim of this topic is not to discuss time series, but to discuss how pandas and numpy can handle or can help you handle time series data. Okay, so we will take that in next lecture. Thank you.